Today on Performance Talks, we have longtime Edgemesh friend Bryan Cantrill, CTO of Oxide Computer Company. Bryan has spent more than 20 years diagnosing systems performance at every level of the stack, from the bottom as a kernel engineer at Sun Microsystems, where he developed DTrace, all the way to the browser, where he worked on innovative data-rich displays powered by Node.js at Join. In today's talk, we go deep into how you should measure performance and look at the importance of understanding systems at scale from first principles.
So yeah, just kind of kick us off. I was talking with a customer today about how one measures performance, and I have a really strong opinion on this. I'm pretty sure that you do too, as the father of DTrace. If you want to measure the performance of the system, I believe that you have to measure it in situ. Like you have to measure real. For us, for web performance, we're talking about real user metrics. Right. And of course, the argument to real user metrics are like synthetic tests and benchmarks.
Right.
But if it's not a real user metric, by definition, it's a fake user metric. So, and DTrace is obviously probably the entire idea is the only way you can actually measure a system is in production. So,
yeah, and then I think that when a software system is running, it's very hard to determine what it's actually doing. It's like, where is the performance of the system going? Why is the system not performing the way I think it should be performing? And that's a very hard question. It's still a very hard question to answer. I think it's like, what is performance? Like, what do you even measure? I mean, of course, I guess the easy answer, the cop-out answer is it does depend. I mean, it depends on, what are you trying to optimize for? Are you trying to optimize for latency? Are you trying to optimize for throughput? Are you trying to optimize for user experience? Are you trying to optimize for efficiency? And all of these things are performance at some level, right? And there are different ways of expressing performance. I think many people don't even know what their answer is to that question. I think they're like, yes, I think I want all of these. I mean, but like, no, okay, yes, these are all like good attributes. But if you had to order these attributes for this particular system, how would you order the attributes? And I think for most systems, you probably do want user experience is probably going to be pretty highly ranked in terms of what your users perceive as performance. But that's not all systems, and systems have different roles and so on. So I think it does depend on the system that's being deployed.
Yeah, it's interesting. I mean, when you talk about what to measure, I always like to work backwards. So it's like, why do we care about this performance?
Right.
Right. So like, if you're, if you've got like a file system, like an NFS file system that a bunch of customers use, and they're all pissed off because they can't open something. Okay, that's why we care about this performance. And in web performance for us, it tends to be some business KPI like conversion rate, right? Why aren't users converting on my website? Are they getting frustrated, or bounce rate or something like that? And then moving backwards from that business requirement or like point of pain, I guess, and then choosing the metric that actually solves that pain or points to that pain versus just collecting metrics for really no reason.
And I think, and you and I, obviously you've got a lot of background in financial services, and I've always kind of been orbiting financial services. The nice thing about finance is there's a really crisp way of connecting especially performance to actually like dollars.
Right.
And my favorite example of this was a natural gas company that was a customer back in the day, and they had to have a regulatory filing in every day. And every day, due to the slow performance of the system, they were a half an hour late, and they were fined $400,000 by the government every day. It's like very, very crisp. It's like, this is a performance problem we need to resolve. And when you're doing high frequency trading, it's very clear. That's great. But as you get further away from those systems, it does become like, okay, yeah, I think like users are dematerializing, right? What does that mean? How do you measure a user that gives up on a website? Because
great question. Yeah. I mean, but that is kind of the point, is like you start with, you never end up with these really clear, and I think that this is kind of an engineering trap, is that because instead of sitting down and saying, let's really take some time and think about this problem and like really work our way backwards, it's like, man, that seems really hard. Instead, let's just throw up these 15 metrics.
Yeah.
That we really don't know what they actually
Yeah.
impact. And then we'll throw those up in Grafana, and then job done, right?
We're done. We check performance. Right.
Yeah. But it's almost never true as you start to break these things down. Like there's almost never a panacea, right? Where it's like, hey, we're going to do this one thing and everything is going to get better. It's like, even in web performance, where it's like, if you're optimizing, there's this thing called the first paint time, or first contentful paint, or last contentful paint. Again, there's 14 metrics that essentially measure the time it takes to go from a blank screen to a non-blank screen. And it's like, well, guess what? I can actually lower that time by pre-fetching assets ahead of time.
Right.
But that comes at a different cost, right? Like resources are not free. So if I want to optimize this one thing, this other thing might suffer.
Or I think maybe I want to do something speculatively that if this action is done, it will be much lower latency. But if the action is not done, it's unnecessary work, and by another metric has made the system perform worse.
Exactly. And then the other thing that really grinds my gears, as I say, is the
steams your clams.
Steams my clams. So we're really good at, and I mean, I think DTrace probably more, to me, my favorite feature of DTrace is that it was so easy to dump a histogram. It was so easy to dump a histogram that you almost never dumped anything else.
Yeah, that's true. Interesting. Yeah.
Whereas, in web performance, I was with a customer today, and, he pulls up real user metrics, and we're looking at a number.
Yeah.
And it's a single number.
Right. Exactly. And you're just like,
and I'm like, okay,
what does that mean?
What does that mean? Like,
right.
And it's the average. It's like, what do you mean it's the average? Also, I hope you don't really mean the average.
Right.
And I think that somewhere along the way, we got good at collecting data, and we got really bad at summarizing data. I feel like that is a super lost art. I think because business people just want one number to look at, and it's like, is that number, I can't put a histogram in the spreadsheet. So like, what number do I put here?
Okay, so yeah, why is this? I think you're onto something there for sure. I also think that we gather data without realizing that with data comes a responsibility to understand the system.
Ooh, yeah.
And I think this is, one of the misconceptions that DTrace always suffered from is people are like, oh, okay, I've got this performance problem, so let me just like rub some DTrace on it. It's like, God, like, no, that's actually, no. So DTrace answers questions for you. So like, what question do you have? Like, I don't know what question I've got. Like, why is it slow? Like, okay, yeah, so, okay, this is going to be kind of a long conversation because unfortunately, like, it's not a genie. You need to actually, and nor is Prometheus, nor are these other things that kind of like give you these metric dumps. In some ways, you're being cursed by having more data because they are not only are you getting just more input, which doesn't necessarily help, but you are deluding yourself into thinking that that's giving you more comprehensibility into the system. But if you don't understand the way the system works, having additional data is actually worse than meaningless. And I think that's the challenge. I think it's like I think it's like, let me just give an average. It's like, well, okay, but an average doesn't actually, that conveys a very fundamental misunderstanding of the system in terms of, I mean, honestly, like, I think you can say, like, if you are talking about an average, you don't understand Amdahl's law, right? And you just not looked at a system where you've had queuing delay become the bottleneck in a parallel system where the average becomes immaterial. It's actually, it's those long tails that are actually relevant.
And I mean, in finance, almost everything's a fat tail. So like, I never wrote an average function until I left Wall Street. I couldn't think, I mean, a median makes sense. But like, I mean, almost everything in performance is a fat tail. I can't think of any performance system that is like really, really nice, or some systems are bimodal, but either way, like an average is never going to get you there. So, I mean, how do you do it? How do you summarize? And I think this is something that I've struggled with the last 4 or 5 years is like, okay, like I'm very comfortable with data. Like I'm very comfortable taking a bunch of data in. I'm very comfortable summarizing it. I'm very comfortable telling a story with it, testing that story. But like customers don't want to do that.
Right.
Customers just want insight, not data. So how do you deliver insight without delivering nonsense, frankly?
Right. Even a good-looking nonsense, the worst kind of nonsense. Like
right.
That actually like, that looks great. Like, okay, we'll actually try to use it. It actually this is nonsense. It doesn't make sense. There's nothing you can do with it.
Right.
No, it's a challenge because I don't know that our systems have become more complicated. They've become more complex. So even as we've gained the ability to gather data from more corners of our system, the systems themselves have grown more complex, and I don't know that our relative understanding has actually gone up or not. Like I think it's kind of gone down.
Yeah, I totally. I mean, one of the things we started to experiment here, and I don't think that there's a general solution to this, but is the idea of instead of handing somebody a histogram might make you feel better as a computer scientist, but probably isn't going to make the customer have any insight. And handing them a single number will make you want to throw up in your mouth a little bit, and might make the customer happy, but it might not mean anything. So instead, what we've started doing is kind of categorizing things. So what we'll say is like, hey, for your website, this is what a fast experience is for this metric. This is what an average experience is for a metric. And this is what a slow experience is, right? And I'm just going to give you, I'm not going to give you one number because I can't really give you one number, but I can give you 3 numbers. And I can say, listen, it used to be that 54% of your users were slow, and now only 14% of your users are slow.
Yeah, interesting.
And I think taking that kind of category approach and splitting the difference, because you don't lose some of the insight from the distribution.
Right.
But you also
another name.
Yeah, and but you're able to kind of relate to it. Like it becomes understandable, which I honestly I think is the thing that you're supposed to do with anytime you're actually giving somebody data. You're actually supposed to be delivering insight, unless it's another machine.
Yeah, and I think in order to give them that insight, like what is the actionability of the data? What am I supposed to do with this? And what I've always found, and I certainly found this to be true, certainly when using DTrace or just generally instrumenting the system, the data usually provokes another question. Like it's like, okay, well, wait a minute, tell me about that. Okay, now tell me about that. Wait a minute, now tell me about that outlier. Where's that coming from? And you're iterating through the data in a very ad hoc fashion to ultimately get to the root of a problem. When you're more monitoring data, I don't know what the actionability is of some of this stuff. Other than like, okay, I get it. Look, it looks good, and you can show customers your knock or whatever. But like, what does this mean? How do you act on it?
And I think that's kind of the core question. Have you built a performance monitoring system that you can interact with? Or have you built a performance monitoring system that just shows you performance monitors?
That's right.
And yeah, I mean, you've used, Prometheus. You guys use that extensively at Jordan.
Yeah.
I mean, would you consider that an interactive system?
This feels like a trap.
I'm just asking. It's not a trap.
Yeah, I you just trying to like blow me up online or whatever. Like
no. I mean, but I'm saying like, is it supposed to be one system? Like, should we? Because building an interactive data system is an incredibly complicated thing.
Yeah, it's complicated, and I think this is the thing that you struggle with, anything like Prometheus or whatever. But it's almost necessarily purpose built. In that,
good point.
That the system itself has to understand the abstractions that it's talking about. The system needs to understand, like, what's memory, what's CPU, what is this thing actually doing, what's meaningful, how do I measure that? And I think in many ways, like the better you get in terms of a system that shows you actionable performance, the more purpose built it is. So it's very hard to build a general purpose system that gives you that kind of iterative insight. I think it's a challenge. I'm not sure that anyone's really done it that well.
Yeah, I mean, there's certainly a bunch of VC companies taking a swing at it. That's probably what this AI ops.
That is not a thing.
That is a thing.
That is not a thing. Is that a
totally is a thing? It is, Brian. I'm so sorry. And here's I've actually been on.
Kidding me? AI ops.
Yeah. Yeah.
Singular.
This is like Cantrill in a box.
Oh my God. This is like Siri with a root is what it is. I mean, it's like, I mean, yeah, you first.
But I mean, I think that this is kind of, and I've been on 2 of these calls where I'm like, you know, one of the things that we've discovered in doing performance monitoring over the last, Jesus, we're both old, over the last very long time.
Yes.
Is that if you want to collect enough information to be able to look backwards and get that feeling of interactivity, the act of collecting that information will actually introduce a systematic load.
Absolutely. Yes.
Like it is a very much, it's always like DTrace was never a collection tool for us. It was always an inspection tool.
I mean, a tool, really. I mean, transient non-fatal pathologies, but you're ultimately like looking at bugs in the system, defects in the system at some level. The system is acting in a way that is surprising and at cross purposes. And that's what DTrace has forwarded those ad hoc queries into those kind of events.
And so if you don't have DTrace and you do have performance monitoring, how do you go from performance monitoring to an introspective system, especially in a world of like transient compute?
Oh, God.
Or like, you don't, I guess.
You don't.
You just throw your hands up.
And this is where we are still in a world of superstition and, restart it and oral tradition and witchcraft and a bunch of other garbage. And we're not understanding the system from first principles. I mean, that's a problem. It's a very, and as we've kind of built these layer cakes of software, especially with the rise of open source software, obviously great, but it means that like now we can we can throw a Kafka at the problem or a Zookeeper at the problem without really understanding like what we do. It's like, don't worry, like we'll do Cassandra for that part. It's like, well, wait a minute, what is this? Is this what is my path now for data? And you're not understanding that fully. You're optimizing for a different kind of performance, namely getting this thing stood up, I guess. But when it begins to operate, when it begins to move sideways, it can be excruciating to figure out what is failing and how, because you don't understand the system from first principles.
Which, I mean, I think because, and I think this is true in a lot of different places in computer science. So in financial services, it was, especially in high frequency trading, we would never, and I mean never, use a library. Forget a system. We would never use a library that we did not fully understand.
Right.
Because the potential side effects of that were so great.
Yeah.
I mean, it's certainly true in other engineering disciplines. I'm pretty sure you're not just willy-nilly pulling things into the OS anyway. So like, it's definitely true in OS development. But like, at what point does that kind of, I need to understand the system fully, become outweighed by like, I need to actually ship product? Like when do you jump the shark?
Right.
And say, and I do think that one of the greatest tricks that Devil ever pulled, the Devil being every infrastructure as a service provider on the planet, is that scale out distributed systems are what you need in order to be successful.
Yes.
Which it's like, man,
good gig.
A single server is actually pretty powerful.
Yeah, it's like, wow, that like I don't know, like that bus ride was pretty slow. It's like, you know what you need? You need 1,000 bus rides. You need 1,000 buses. You're like, okay, I guess I do. It's like, okay. I mean, it's a good gig if you're an infrastructure provider.
But I mean, this is kind of, I think, an old engineer versus, young engineer is knowing when that line is. Like, for example, I have always believed, and we will probably always believe this. I think I might be bigoted at this point, but like your data, like where you store your data, your database, and the code that you're going to run against that data should just be the same thing. Like, and this is a byproduct of history for me, right? So my history is very much Iverson APL to J to K to Q. You know, so that array-based language, but also Mathematica, also like those languages have at their fundamental tenet the idea that like we're going to store data and do work on data in the same system.
Yeah.
Because you would never, I mean, Erlang, I think to a large extent was influenced by a lot of that too, but because you don't want to move data, right? And when you start to separate analytics from data, like the first thing you need to do is have something in the middle to talk to the two.
Right.
It's like, well, now we need a message bus. Next thing you know, you got a JVM that you need to like start with a crankshaft
Right.
to like get that thing rammed up so that you can pass messages between two systems that inherently should talk to one another anyway. But like, how do you know? Like, when's the point? Like, for example, like I don't write my own file system because that would be moronic.
Right.
And I don't even write my own compression because I know that ZFS compression is fantastic and that I can swap it in and that it can move around and it's transparent. But like, as the old, like, when do you say, hey, this is actually a good job for this tool? And how much do you need to understand that tool before you use it? I think is a big one.
It is a big question, and I think, and we're constantly getting it wrong. And you know, I think it's a natural oscillation for a technologist to be optimistic about a technology. It's like, oh, okay, this technology seems to be a good fit for my problem. And on the one hand, you want to have that optimism, and you don't want to build everything yourself. On the other hand, you need to be prepared to walk away from that when it's clear that it's actually creating more problems than it's solving. And it's very hard to know when and where to do that. And I feel that I've erred on both sides of that. Although, you know what?
Have you put systems into production with components that you didn't have somebody on staff that truly understood down to root cause? Yeah.
Oh, sure. I feel that, haven't we all? I mean, I feel that like, well, no, in that like not deliberately, but I mean, ultimately, all of these systems have been downloaded off of the internet at some level.
Right.
You know, ultimately you've got, and that, I feel like we crossed that Rubicon a long time ago. And before we crossed that Rubicon, we were inheriting systems because you can't rewrite the system from scratch with every iteration. So you've got stuff that's just kind of floated along from the 70s.
Sure.
And so you either because it floated to you from the past or it floated to you from the internet, it just floated to you. You didn't deliberately design it. Now, one would assume that's not the core of one's system, but you have had these components. So yeah, I definitely feel like that I've had components that and usually I have been most dangerous when I have not thought I've had those components.
Ooh, what's an example of that?
Ooh, firmware.
Of a complexity that snuck out from underneath the bed and stole all your toys and set your clothes on fire.
Firmware.
Well, firmware is just evil. Firmware's always evil.
But firmware is this ambient thing that you don't control, that is in this kind of silent surround. You don't think about it, and then you deploy a system, and all of a sudden the system is the animal brain of the system. It has developed a lesion that you didn't even know it had the capacity to have because it's deep in the stack. And so I feel that at some point in my life or another, I have been screwed by effectively every layer of firmware in the box and the system. And it is remarkable when you look at, you rip open a machine, even a putatively simple one, there's a lot of firmware. And so at some level, that these are components you don't understand. I mean, what we're doing at Oxide is understanding all those things from first principles, and it's hard. It's time consuming.